Sahil, and today we're going to be talking about linked lists. So a linked list is a type of data structure that allows us to store objects in various parts of memory, and these objects will not necessarily be contiguous in memory as opposed to a traditional data structure such as an array or a vector. And the main advantage of this is that we have an efficient insertion and removal that does not necessitate us copying over the data and then performing the operation that we would like, rather that we can simply do it in place per se. And so how this is represented in memory is we have a linked list where we have object 1 here, object 2 here, 3, and 4. And what this necessitates is object 1 could be anywhere in memory, object 2 could be anywhere in memory, object 3 could be even behind object 4 in memory, object 2 and object 4. And the only thing that we need is that each of these knows its own value and it knows where the next node is. So we'd know 1 would know where 2 is, 2 would know where 3 is, and 3 would know where 4 is. And this is opposed to a normal vector approach where we would have all 4 elements in contiguous memory. And the main advantage of this is if we were to add a 5th element here, we would have to copy over the entire array and then append it. While here we can just say 4, here's where 5 lives, and allocate 5 in memory. So this is a O of 1 operation as opposed to an O of n operation. So a good way to represent this would be houses in a neighborhood. So let's say we have Alice, Bob, Kathy, Dave, and Evelyn. So Alice knows where Bob is, and Bob knows where Kathy is, and Kathy knows where David is, and David knows where Evelyn is, and you know where Alice is. So this allows us to get to any of these houses. However, it is slightly more difficult than a vector where we can just say, give me the 3rd house. Instead, we have to say, okay, I know where Alice is, I have no idea where Bob is, or I have no idea where Kathy is. So I can say, hey Alice, you know where Bob is? Cool. So then we get to Bob, and then Bob knows where Kathy is. So then we can get to the 3rd element by going through Alice and Bob, the first 2 elements. And then through this, we can traverse any element. So to get to Evelyn, we'd say, okay, Alice, where's Bob? Bob, where's Kathy? Kathy, where's Dave? Dave, where is Evelyn? And through this, we're able to traverse all 5 people's houses. And this can also be implemented such that it's a doubly linked list, which just means that each person knows who its previous element was. So Evelyn would know where Dave is, Dave would know where Kathy is, Kathy would know where Bob is, and Bob would know where Alice is. And this allows us to get to any element from either side. So we'd also know where Evelyn is in such an implementation. So if we wanted to get to Dave, we could just simply say, okay, I'm going to go through Evelyn to Dave. Or if I want to get to, rather than having to go through Alice, through Bob, to Kathy, to Dave. And so as you can see, this would be faster. So yeah, and in C++ code, this would be implemented by having a node which consists of any type of object. It could be an int, it could be an elephant, it could be a watermelon, it could be a double, and it could be a person in this case. And each node has a value. So the value of this node would be Alice herself. And each node also has a pointer to its previous element and a pointer to its next element. So in this case, this node would have a next element of that points to the node that contains Bob, and its previous pointer would contain nothing because this is the first pointer. Similarly, here Evelyn would have no subsequent pointer. Its previous pointer would point to the node that encompasses Dave, and its value would be Evelyn. So as you can see, a node can be written with templates and generics to allow us to have any value stored, and the approach is the same, just have a pointer to the next element, a pointer to the previous element in a doubly linked list, which is the way that the STL uses it in C++, and simply have the value, and this allows efficient insertion and removal, because if we wanted to insert a value in between Kathy and Dave, let's say we wanted to insert, I don't know, Igloo. If we wanted to insert Igloo here, we would just say, hey, Kathy, point to Igloo, and Igloo, point to Dave. Then we do that. This involves simply getting to Kathy or getting to Dave, then accessing these, changing what the pointers point to, creating a new object in memory, and then having a new Igloo. Then we could put any type of value in this Igloo. So let's say that we have our friend, what do we want to name our friend? Steve. We'll put in Steve in the Igloo. So then we have this list. And so as you can see, that is a very efficient insertion rather than in a vector, where if the vector is full, you'd have to change the memory of every single object and then add in. So yeah, that's like this.